So the ATR for this instrument is small orbit diamond ATR, which is very robust and very good. So the way that we do, so basically we lose this knob and remove the transmission accessory, and that accessory, it does have a magnet by itself, and then fit the ATR in here. So now by the time that we place the ATR there, it just tells us that I recognize this is a smart accessory. What we mean by a smart means it recognizes by itself. So all of the companies just it says smart orbit is just there. So click OK, and then we can go from there. So we OK that, and then I don't want to just do another test. So then we can go again to experiment setup and to see if it's recognized by itself, and actually it shows that it's working fine, and it's recognized that it is smart orbit, as you can see here. Okay, let's just do another measurement. Before we do a measurement, we secure this knob in here. So there are two sides. This is a bigger part that should be toward of the ATR, and the smaller one is just going to go back. So anyway, so now it's ready, just like whatever you do in a spectroscopy. So you need to do a collect background. So once again, so after 3 scan, okay, so it's auto gaining by itself. So after 3 scan, 1, 2, 3, bang, this is again the spectrum of the ATR. So those are natural peaks of diamond. This kind of diamond, of course, diamond, it doesn't have a absorption in IR, but this is weak, and so it shows here. That's the nature of diamond. And this is water vapor again, CO2, water vapor, CO2. So we don't need the background, so let's just do some measurement. Okay, now let's just collect sample, and you're gonna say okay, and then after, like what I explained it before, after 3 scan, 1, 2, 3, and bang, beautiful. And it just basically, I know I'm a chemist, I know this is there's not much CH stretching in here, mostly polydimethyl siloxane. This is a PDMS, a soft polymer, so it just shows. So you don't need to go that much scan, so maybe 8 scan is enough, but anyway, I just gonna leave it as it is. So it's done. So basically you're gonna say yes, because you're gonna keep it in the Windows. Okay, we open a new Windows for another measurement. Okay, now go back to anti-static plastic bag. So those thing is, there's a technology just used in this thing. So basically, if you carry electronics in this ordinary bag, it's gonna damage, because those component is just going to be damaged by static electricity. Should be inside of this kind of bag. So this is not only one layer. So the difference, and there is a difference between inside and outside layer, and also there is a coating. This coating is aluminum is inside. So okay, let's just start from uh, inner layer. So you do collect for inner layer, collect sample, and so this is the inner layer. So again, after 3 scan, 1, 2, 3, bang. So a chemist knows definitely this is polyethylene or polypropylene. This is too much CH stretching and one CH bending, and that's it. That's a long chain vibration of that aliphatic long chain ring. Not ring, I'm just chain. So this is the inside though. So the inside is polyethylene or polypropylene. So it's done. I'm just gonna say yes. Okay, and the second one is just gonna be the outside layer. I'm gonna open it and turn it. Okay, so now I'm gonna say collect sample again. So now again, after 3 scan, 1, 2, 3, bang. So now it's totally different. So you see not much CH stretching, not much. So mostly is in here. That's just very big carbonyl groups in here. So it's totally different from outside layer. So again, after 32 scanners, which is too much, you're gonna see the spectrum. So I'm gonna say yes. I'm gonna say yes. And also I marked them down inside. The red one, the blue one is going to be outside. So basically, so in next experiment that we just want to do a live research, we're going to measure that one. Next example is just a thin film of the paint on metal. So basically what I'm going to do, I'm going to place in here. So actually you can just background with the metal first and then do a sample on the paint, but it doesn't matter because the peak is very strong. So again, I'm gonna open new windows. So then I'm gonna say collect sample. Again, after 3 scan, 2, 3. So here it is, a very big peak, very good peaks, and actually just shows the organic material on the metal is there. So this is I mean, not a very big intensity, but mostly not aromatic, aliphatic CH stretching, and some feelers or inorganic thing is here. So I'm going to place them yes. And the last example is a thin film of oxide, metal oxide. I don't know yet what is this. I just sand this area, so that's oxide layer is there. So let's see what it is. Since this is a very thin film, so what I'm gonna do, I'm gonna do a background in here. So a background in here, and then I'm going to do the measurement with the actual oxide layer. For ATR sampling, I have 5 different samples that I'm going to do one by one. The first one is a soft polymer. The second one is a protective electronic bag coating, that anti-statics, and also the paint on metal, and also thin film oxide on metal. As you see, some part of area are just removed by sanding. So let's just start with when we have already done the background. Let's just do the soft polymer. So basically, there is a knob. This knob is not allowed to put more pressure. Whatever, if you put more, if you turn it more, nothing is going to happen. So there is a certain pressure just controlled by this. So you should not turn it with this. You're going to break the diamond or something. So let's just go and collect sample. Okay, the background is already done. So I'm going to remove the background, clear, and then I'm going to place the paint, not the paint, I'm sorry. So we do background first again. So we do background, and then after background is finished, we're gonna just measure one by one and do a library search to see what material was used in this handle, goggle handle. So are they the same or a different company? So that's gonna tell us. So I don't need this thing, and then I'm gonna place this one, and then fasten this. So basically now is in place. So I'm gonna say again, collect sample, and say yes, okay. Again, once again, after 3 scan, 1, 2, 3, back. This is the spectrum of this handle. So basically, we're gonna see that it does have carbonyl groups, aliphatic CH, not much aromatic CH because it's below 3000 centimeter minus. So a little OH, so you can see here a little OH. So of course this is just because of subtracting from diamond. It doesn't matter, so we don't care about this thing. So of course I'm going to say yes, I need this one on display. Let's just start, let's just put this one, the camera away, and just put this one in here, and then we're going to go from there. Okay, so we placed the next goggle handle in here. So let's just go again, do the measurement, collect sample. Okay, once again after 3 scan, so we're gonna see if these two goggles are the same or not. Obviously it's not. They're not the same at all. So basically huge OH stretching in here. So even here also you're gonna see a little much more CH stretching, and also a little peaks in here that shows that we have aromatics CH stretching. So basically definitely, even as a chemist, I can't say they are not the same at all. So of course I'm going to say yes, and then we're going to do a library check. So this is the two peaks. You see the difference. So they are not the same. So that goggle and this one's not made at the same company. Okay, now what I'm gonna do, I'm gonna go to view. I'm gonna select stack spectra. So basically there are gonna be different, so it's going to be up and down. So at the up one that has less OH, let's just see, and in a search area. So I'm going to go to search pics. So it's just going to do some computing, and then it's just going to give us example, and basically it says it is cellulose propionate. So basically it is cellulose propionate, exactly the same. Then let's just see the other one. So basically I'm talking about this one. Let's see what it is. So go analyze, again go to search, again you start searching, and actually this says polyurethane base. So basically, of course, not exactly match. The matching factor here is just less, is 74%. So again, so it says this is almost polyurethane base. Maybe the coding is there. So now let's just go back and see what was that thin film. Was just metal film and the metal. What was it? So here are the pics. So I'm gonna say search it. So I just do some measurement, and here it is. It says magnesium oxide or something. So somehow it's the same, but there are other options there. So you can go lower. So again, magnesium hydroxide layer. So basically it could be this one. Okay, the matching factor is 70%. It's not much. Maybe I don't have this kind of type of oxide in my library. So the last one is a PDMS that we know. So let's see, it was in Windows 2. So let's just search this one. Search. So basically it's gonna say silicone rubber, as you can see. So that's the matching factor is 96%. 96%. Definitely this is silicone rubber. So it is correct. So thank you for watching, and I hope that I can see you in my next video.